quadratics right here, guys. Again, we're going to ask ourselves the following three questions. Which form should I use? Should I use vertex form to model this? Should I use x-intercept form to model, or should I use standard form to model?
If we're doing what?
You always want to ask yourself which of these three forms you're going to use first. Are you using vertex form? Are you using x-intercept form? Or are you going to use standard form to start the problem? Okay? So, example 3, writing a quadratic equation using, and this is going to get kind of tough, using 3 points. Okay? And this is going to kind of spill over to the next page. So, could I get a volunteer to read example 3 for me right now?
A former NASA employee designs a model airplane that flies in the parabolic path. The table shows the height h in feet and the plane t seconds after starting the flight path. Write a function to approximate the height of the model airplane after t seconds. How long is the model airplane above 18 feet?
Okay, so when they give you 3 points like this right here, guys, I think it's a great idea here for this to use standard form on this, and I'll show you why here. Right? So we're going to use standard form for this. So when given 3 points, I think it's a good idea to use standard form. So again, they're telling them about this model airplane that flies in what kind of a path, kids? It's going to be a parabolic path, yep. Okay, so the table's on the next page here, kids. This path that it's flying on says the following. After your time t, after one, I've got to go back and look at the units. We'll get that in the table. It says the height is in what, kids? Feet. T. Okay, so maybe we want to go in this table. Time t is going to be measured in seconds up here. And what was the height measured in? Okay, so this model takes off. After 1 second, how many feet in the air is it? Okay, and after 2 seconds it is. And then finally in 3 seconds, ooh, it's coming back down again, right? So it was on its way up and now it's coming back down. So that would be some kind of a path that looks like this maybe. Okay? So we need to write a function that's going to model this right here. And if you notice in example 3, at the title of that example, it said, writing a function using how many points? 3 points. Okay, here's how this is going to work. I know that everything's measured up here in t and h, but I'm going to kind of pretend like the left-hand side is an x column and this is a y column over here. Okay? Now, it doesn't matter to me. Whatever you want to use is fine. I don't care. But I'm going to go ahead and go off the idea that we're using standard form for this. Okay, we're going to go off this idea that y equals ax squared plus bx plus c. And we're going to pick 3 points to plug in. Which 3 points do you want to pick? I have an idea. You want to know which 3 points I want to pick? Pick the first. It's okay if I pick the first 3. Is that okay? Okay. I'm going to pick these first 3 points right here, kids. Okay. Basically what I'm going to do is I'm going to plug in these x values and plug in these y values. So write this first equation, kids. What would you plug in for y right here in this first equation, given the point that after 1 second you're 19.1 feet in the air? What would you plug in for y? What would you plug in for y given this first point, kids? 1 or 19.1? Okay, so first equation we would write would be you're 19.1 feet in the air after 1 second. So it would be a times 1 squared. Okay, what is, I'll just write it this way. Plus b times 1 plus the c value. You guys okay with that, first of all? Are we okay with that? Yachty or naughty? Okay. What's the second equation going to be if I use this point right here, kids? Two comma 20.4. Let's write another equation. What would you plug in for y using this point?
20.4.
Thank you. What's going in for x then, kids? 2. So we're going to have a times 2 squared plus b times 2 plus c. Awesome. What's the third one going to look like if I use 3 comma 19.9, kiddos?
19.9 equals A, and then C is 3 squared plus B, and then C plus C.
Okay. Now I'm going to make this a bit smaller so I have some room to work. But kids, right here, can you figure out what 1 squared is right here that I'm pointing at in the first equation?
Yeah.
What is 1 squared? Well, it's 1. Could you figure out 2 squared here in the second equation? You could, couldn't you? Could you figure out 3 squared right here? Absolutely. Guys, how many equations did we form? 3 equations. How many unknowns? 3. Haven't we been down this road with 3 equations and 3 unknowns to have to find some values to write an equation? We have, haven't we? Okay, our job right here is the following. I'm going to take this part right here and let's move forward. Let's simplify this a bit and let's talk about how to solve this. What's 1 squared going to be in this first equation? Okay, so the way I'm going to write this first equation is 19.1 equals, 1a is like a. Isn't this like 1b right here, kids? Plus b plus c then. Okay? Again, we're trying to write a model that models this path with the table of information that's up there. Okay? All right, how would you write the second equation, simplifying some stuff then? 20.4 equals what? How many a?
4.
4a plus 2b plus c. What's your last equation going to look like after I go ahead and simplify some expressions?
19.9 equals 9a plus 3b plus c.
Awesome. Now kids, when we started solving these right here, how do you find the values for a, b, and c to make this all true? The first thing that we asked ourselves is to say, hey, which variable up there would be the easiest to get the same coefficients for? Well, it turns out when you're working with quadratics, do you see a variable up there that's exactly the same in all 3? Do you see one up there? There's a plus c and everything. I'm going to look at this column right here and say, hey, everything right here is the same. So from this right here, I say, well, if the c's are the same and the signs are the same, would I add or subtract row 1 and row 2? Subtract, right? Same thing here. C and C, both positives. Subtract. So let's do that to form a new equation here. We're going to go from 3 equations with 3 unknowns down to 2 equations with 2 unknowns. So help me, kids. What's 19.1 minus 20.4?
Negative 1 point something 3.
Good. What's a minus 4a, kids? Negative 3a, right? How about b minus 2b? Minus 1b. Ah, how about the c minus c? We're punting. Get out of here, right? C's are gone. First one. Okay, next one. Excuse me. Holy cow. 20.4 minus 19.9 is 0.5. How about 4a minus the 9a, kids?
Negative 5a.
2b minus 3b. Oh, minus 1b. Well, would you looky there? We've gone from 3 equations to 3 unknowns down to 2 equations, 2 unknowns, by taking row 1 minus row 2 and row 2 minus row 3. Hey, in that new system, does anything stand out? Or is there anything in there that can help us move forward? 1b. Oh my gosh, the 1b's are the same. How about the signs of the 1b's? They're the same also. So if they're the same, what am I going to do with these 2 functions right here, or these 2 equations? Am I going to add them or subtract them? Subtract. Okay, help me, kids. Negative 1.3 minus 0.5.
Negative 1.8.
How about -3 minus -5? So when you subtract that -5, got to be careful. It is 2a. Kids, right here, what are the 1b's going to do to each other? What am I allowed to solve for right now?
-1a equals 2a. Divide everything by 2.
So I can divide everything by 2. What's that make this a value, kids? -0.9. Okay, so I know a is -0.9. What other variables do I need to solve for now, kids? B and C. Okay, so I'm going to move this work over to the left here. Give me a second, please. Okay. Kids, if I work backwards into one of these equations, I'm going to take this a and plug it in right up here now. So I'm going to use the top one. Is that okay, kids? What am I going to replace a with?
-0.9.
So I'm going to have -1.3 equals -3 times -0.9 minus 1b. Okay, this becomes -1.3 equals 2.7 minus 1b. Tell me what to do, kids.
You subtract 2.7 from both sides.
So I have -4 equals -1b. So what's that make the b value, kids? How much, Jaden?
4.
Exactly. B is going to be 4. What do we have left to solve for, kids? C. So I've gotten here, so I'm going to go back up into one of these equations up here. Maybe this top one right here. I had 19.1 equals A plus B plus C. But we know what two values now, kids.
B and A.
So I could plug in B and A and solve for what now? Okay, so help me out here. This is going to be 19.1. That's this first equation I'm using. That's equal to my A value of -0.9 plus the B value, which is 4, plus C. Okay. What is -0.9 plus 4, kids? 3.1. How are you going to solve for C, kids?
Add them together. Minus the...
Yep. So to get C alone, wouldn't I take 19.1 minus how much, kids?
3.1.
Yep. So what's that? What's 19.1 minus 3.1, kids?
16.
C is equal to 16. All right, kids, right here then. We've figured out what A is. What's the A value? What's the A value again?
-0.9.
-0.9. What's the B value?
4.
And what's the C value?
16.
So to write an equation to model this data, how many points did we choose? 3. How many equations did we write in standard form? 3. And we use the things that we know about systems of 3 equations with 3 unknowns to solve for A, B, and C. So to write a path for this right here, for this data right here, we would end up with the following. We would end up with, for this table, a good model would be y equals, okay, if I'm using this again, ax squared plus bx plus c, what's taking the place of a now, kids? Wasn't it -0.9 times
X squared.
plus bx? What do we get for the b value?
4.
plus our C value, which was what?
60.
There it is. Now think about it, kids. This plane started here, kind of went up in the air and started going down. So this is kind of like an arch shape, isn't it? Kind of like an arch shape. Take a look at my A value. Is my A value negative or positive here?
Negative.
It's negative, which would mean that is going to be some kind of an arch shape. So it kind of matches the path that we would take there. All right? So if I say, hey, here's a table of information, I want you to write 3 equations with 3 unknowns. Which variable dropped out first? C dropped out first, then B dropped out. You're able to solve for A. Use A to plug back in to find your B value. Then use A and B to find C. Okay, so really, it's just a matter of plugging stuff in and solving a system of equations. So a model for this path right here would be y equals negative 0.9x squared plus 4x plus 16. Who has a calculator handy? You want to do something for me?
Yeah.
Okay. I want you to type in everywhere where there's an x right here with parentheses. So you're going to go negative 0.9 parenthesis. Plug in 5 for me. Everywhere where there's an x, plug in a 5. So 5 parentheses squared plus 4 times in parentheses a 5 here. So everywhere there's an x, you're putting like a parenthesis 5 there.
13.5.
Oh my goodness. So that model that we got, we didn't even put these points in here, did we? But when I plugged in 5 right here, it kicked out what?
13.5.
So you know you are
Right.
right. Okay? So what points did I suggest maybe that you use first? Well, I said use the first 3 points. Now, here's the good news. You don't have to use the first 3 all the time. You can use any 3, and it will still work. Okay? All right. Guys, isn't that a lot of work right there? It is. Okay? So the next thing that we're going to look at, I think you're going to kind of like. All right? Example 4, same exact thing. I can make you do all this again, and you'll have to at some point. All right? But sometimes we can use quadratic regressions. Sometimes we get points that are plotted. Let me just do this real quickly up here on the board. Sometimes you get points that are maybe plotted in a coordinate plane that kind of look like this. Now, is that a perfect parabola, what I just plotted right here? Is that a perfect parabola that I just plotted there? The answer is no. But is it an approximate parabola? Okay, you guys remember way early in chapter 2, we had like that one calculator that you put all your points in and then put a fitted line in there and it gave you the equation for that line? You remember that? Okay. Well, the same can hold true for a family of quadratics. We can put in a fitted parabola to try and be around some of those points right here. And that's what this is all about. Quadratic regression. If they say use quadratic regression, I'm going to show you how to use Desmos to make this work. So example 4 is going to be an all Desmos example. I think I want you to have that open today so you get used to the finger strokes because this is going to be very new for you. So make sure you're into Desmos with this. Okay, example 4. It says the table shows fuel efficiencies of a vehicle at different speeds. It says write a function that models the data, use the model to, and again, anytime you're using regression, the model is just an approximation. Okay? Guys, when you're going 23 miles per hour, how many miles per gallon are you getting with this particular vehicle? What's it say here? 17.1. What appears to be the best speed to drive to get the best fuel mileage in that vehicle, according to that table? What appears to be about the best speed to drive? 50. Okay? Did you guys know that most vehicles are designed or engineered so that your maximum fuel efficiency occurs at 55 miles an hour? Now, why would they do that? A, it's the law, right? And B, most of your driving really is out on 2-lane highways, isn't it? Okay? Let's look at this right here. Here's how this is going to work. We're going to jump into Desmos with this, and I'm going to show you what you need to do. I'm going to kind of go split screen with this up here and tell you what to do. So anytime they use the phrase, I want you to come up with a quadratic regression or an approximation for data, where are you headed to again?
Desmos.
Okay, let's go split screen. This is so cool. Oh, look at me. I'm going split screen. It's kind of like watching the Vikings in the race at the same time. You guys don't share my enthusiasm this morning. What's up with that? Okay, clear these out. Here's the first thing you're going to do, kids. So, when you have tables of information like this, get into decimals for me first. Here's what I want you to do. You see this plus sign up here in the top left corner of decimals? Click on that. Do you guys see the table option right there? Everybody see table option? Go ahead and click that table option. It's going to kick a table out for you. Okay? Now I want you to go ahead and put all those points in. All of those points in. 23, 17.1.
Carson,
Yeah.
you put 27.
Oh, thank you so much. I have to make mistakes intentionally up here. See, we're all paying attention. Thanks, Jaden.
Yeah.
What's the next one I need to put in, kids?
34, 23.4,
Okay. See if I-
42,
42.
27.5, 47, 28.6, 50, 29.6, 61, 26.2.
So what's happening to my fuel mileage now? The faster I start going, I was getting 29.6 miles per gallon at 50 miles per hour, but now what's happening to my fuel mileage? My fuel mileage was always increasing, but now it's starting to do what? Decrease, right?
And 72 and 22.
Okay. All right, I have that data in there. You guys make sure you get that data in there as well. And then I'm going to adjust my window here, and I'm going to show you how to do this to make this work. Okay? Let me know when you have your data in first. Everybody have their data in there? Anybody need more time getting data in there? Give me some sort of sign that you're alive right now. Anybody need more time getting that data in there? Is that a no? Okay. I want to talk about this right here, guys. Look at my x values. What's the lowest x value we're working with here?
23.
23, and what's the highest x value?
70.
So I'd like to see a model of this right here. So up here you have this little graph settings tool up here. I want you to click on that, graph settings. Okay. You see where it says x-axis right here? Our lowest value was 23. So I'm going to get something a little bit lower than that. So on this x-axis part right here, I'm going to put in, say, 20. Okay? Now, what was the highest x value in the table, kids?
72.
72. So I'm going to go a little bit more than 72. I might go ahead and call it 80. Okay, and then this step over here, I think a good step would say go by tens, because go to 20 to 80, those are all sets of 10s. So I'm going to put that in there. Now, my y values here. I want to make sure this works. What's the lowest y value in this, kids? So I might put 10 in as a minimum. What's the highest y value?
29.6.
So I might put in something like 30 here. Whoops, I want to put 30 in. Clear all that out and go 30. And I might say, go by 10s. All right? Guys, I have all my points right here. Now, does that look like it's giving you some kind of a parabolic path right there? This goes from increasing then to what? Goes from increasing then to what, kids? Decreasing, okay? What we would like to do is come up with an approximation for a curve for those points, and here's how this works, all right? This is going to be very new for you, but it's pretty darn cool, okay? This is the part that'll be new for you. Here's how it works. First of all, we're going to write an equation of standard form. So what's the general form for standard form up there on the board again?
Y equals ax squared plus bx plus c.
Okay, watch this right here. Here's how this works, okay? You have to pay attention to detail on this. Here's what you're going to type in first. You're going to type y in field 2, okay? And then you're going to put a 1 right after it. This is really important. And in fact, I might write this down by example 4, okay? I'm going to go into this quickly and I'm going to say, on your notes, put in data first. So you got to go to your table mode and put in data first. Okay? Then, to do linear regression, you have to type this in, y1, and then you have to do this little symbol. Okay? So I'm going to go in here and I'll show you where that symbol is. You have to click on, you see this little keyboard right here? Click on your keyboard. Okay? See this ABC option down here? Click on your ABC option, and you're going to click on this little squiggly mark, this little. You guys okay with that? Okay, what's general form then, kids? AX
Squared.
plus
BX.
plus. Now let me show you why we have to put the Y1 in here, kids. How is this table labeled up here? Y1. So what do you think we're going to have to put in for X's? So the way we're going to type this second part in down here, we're going to type in Y1 is approximately, here we go. You're going to type in A, X, then you're going to put a 1 behind it, AX1, and then you're going to put plus. Anybody got to guess what we're going to put in next? B, X, what? 1. Anybody got to guess what we're going to put in next? And I forgot something here, and we'll come back to it. Yeah. Plus C. What did I forget to put in up here, kids, at AX1? Should have been AX squared. Ooh, well, isn't that pretty? Doesn't that graph kind of approximate this point in a parabolic path right here, kids? It does, doesn't it? Okay. What do they give you as an A value down here, kids? So negative 0.015. How about a B value? What do they give you for a B value? About 1.55, don't they? What do they give you for the C value? Negative what? You guys should have those values in front of you right now. Is there anybody that didn't get that? Okay. The kicker here, guys, is this. When you type this in to get an approximation, what do you have to type in for the Y? You have to type in Y what? 1 is approximately AX 1 squared plus BX1 plus C. All right? So I'm going to type this, or I'm going to write this right here. The thing you have to type in, Y1 in decimals, is approximately AX 1 squared plus BX1. And that's how you get your formula. Okay, so you guys look at decimals right here. A good approximation for this would be about Y equals, help me out, kids. What was the A value? Negative point, was it 0.15-ish? What did it say on your computer? Can I see this again, Grant? What was the A value again about?
0.15.
0.015, okay, negative 0.015. And then what am I going to put behind the negative 0.015 since that was the A value? Again, we're writing a function in standard form, so negative 0.015 x squared, yep. Plus my B value. What was the B value in the data, kids?
1.56.
About 1.56x then. Plus the C value that I had, and I think I typed everything in right. I'm not sure, but I'm pretty sure I typed everything in right. What do we have for C value? Minus about 10 point what? Minus about 10.86, okay? So I should change that to a minus. Whew. Okay, and then it says use the model to approximate the optimal driving speed. Well, once I have that in there, I'm just going to go to the graph and say, well, you know what? The optimal driving speed looks like it's right up here at the vertex. About how fast is optimal, kids? Pretty close to 50.8 miles per hour. Okay. Let me ask a question. Quadratic regression. Are you guys okay putting data in a table, first field? That's my first question. Okay, and then to get that approximate curve right here, do you know what you need to type in to get this A, B, and C data down here? By the way, we talked about R values. This R value, 0.97, really close to what value? 1. Is this a strong correlation or not? A very strong correlation, you bet. Okay, that's pretty cool stuff right there, kids. Anybody ever use regression in decimals like that before? Have you? Pretty sweet. It's pretty sweet stuff. Okay. All right. Well, I'm going to go ahead and stop here.